Evening. Uh, Today we're going to be doing mechanics. Tomorrow on Wednesday there's going to be a mechanics CA exam, and currently it's week 9. I might be posting a little late, but it's all good. As long as I'm here, we'll hopefully be fine. And yeah, I just want to get through this 15 questions as quickly as possible so I don't waste your time. Okay, so starting with question 1. A possible equation of motion of a particle moving in the positive direction at a constant speed. So when they say positive direction, this means that V is positive. Meaning when V is positive, that means, what does that mean? Well, look, we first have to note the formulas of UARM and URM. We should know that X is equal to 1 over 2 AT squared plus V0T plus X0. X0's initial position, V0 is initial velocity, and A is acceleration, T is time. And X represents the distance or displacement, depending on if you include this or not. V is equal to AT plus V0, V0 being initial velocity. And yeah, these are the main rules for UARM. But for URM, velocity is constant, meaning that X is normally just equal to Vt plus X0. And URM. Okay, well over here, when there's a constant velocity, meaning that it's constant speed in the positive direction, that means if there's constant speed, that means it's uniform rectilinear motion, meaning that we'll be excluding the UARM formulas. We're only left with this. X equals Vt plus X0. Now, over here, they don't state that it has initial position, but that doesn't matter because the main idea is X equals Vt. So that means in a positive direction, the formula always has to be it can never be minus Vt plus X0. It always has to be positive. So let's look at the examples here. And also there's never t squared, because when it's t squared, that's only in the case where there's UARM, because t squared is for in the case when there's acceleration. In URM, there's no acceleration. So we can immediately discard this, and yeah, these two are wrong. So we're only left with these three, and we don't know them still. They said positive direction, and if we look closely here, this V over here, this represents V. And they said it's moving in the positive direction. Is this positive? No, this is negative. So if it's V is less than 0, then this is incorrect. They want V when it's positive. And over here, V is positive. It's the same as over here. It's the same as saying X equals 1t minus 1, and 1 is greater than 0. So number 1 is solved. Moving on. Okay, now number 2, they're asking what is the acceleration of the object between 0 seconds and 2 seconds. So we have to find the time interval. When they're asking for the acceleration in a VT graph, we have to do the rise over run, or just the slope formula. y2 minus y1 over x2 minus x1. So easy, simple. I guess we'll say y1, x1 will be 0, 0, 0, 0, and x2, y2 will be 2, 4. So we'll be left with 4 over 2. Or it originally comes from 4 minus 0 over 2 minus 0, which is equal to 4 over 2, which is equal to 2 meters per second squared. Now we have meters per second squared. We can put this down here, 2 meters per second squared. This is our acceleration in the time interval 0 seconds to 2 seconds. When they're asking for what is the net displacement of the object, you have to look here and notice when you have the VT graph, the area under the VT graph, you have to always remember this, the area under is equal to the net displacement. So let's look. Let's find, this shape is a trapezoid here. So let's see. This length here, from 2 to 6, the length here is 4. From here to here, it's 10, I believe so. And the height, oh, sorry. Yeah, the height is 4. So now we'll apply the formula over here for, oh god, okay, sorry, that's fine. Now we'll just use, now that we have like the shape here, the trapezoid, we have the height 4, the top as 4 and the bottom as 10. We'll do 10 plus 4 over 2 times 4, because we're doing big base plus small base over 2 times height. This is deriving from this. So 10 plus 14 is 14. 14 over 2 times 4 is equal to 20. Sorry, it's equal to 28. Okay, so now we have the displacement or the area under this graph, which is 28. And remember, this is only in the VT graph. This is question 3 now, and we have over here it's stating a bus starts from rest at point A, and okay, well, this is a scenario when there's acceleration, then and like different phases. The best way to solve this is through using a graph. Since doing this without the graph, it will take far too long. So let's just use the graph. So they're stating it starts from rest. We'll use a VT graph, because if you use an XT graph, it will be curves everywhere. It will be super complicated. VT graph is obviously the best way to do this. So in the VT graph, when it accelerates, that means obviously to be sloping upwards. So 2, it doesn't really have to be perfectly to scale, but it's stating here 2 meters per second squared. It's accelerating it's just accelerating from point A. We'll call this point A, and it'll accelerate 2 meters per second until for 10 seconds. So it will reach 10 seconds over here. Remember, this is V and over here is T. So 10 seconds over here. Now we have our first time interval, and the slope of this line here should be 2, not the actual length, but the slope. And to find the height from here, you have to do, like, we should know that over here is V, and we know that V is equal to AT plus V0. V0 is already equal to 0, as stated here. When it's at rest, V0 is equal to 0. So it will just be, so we can just cancel this out, and we can just leave V equals AT. The acceleration is 2, and the time is 10. So velocity is equal to 20 meters per second. So our height is going to be 20 meters per second. Now they're stating that now they keep at this speed. They don't really specify the speed, but now that we found the speed, they specified that we'll be staying at the speed for 30 seconds. Now remember, this is not perfectly to scale, but the idea is it goes for 30 seconds. So 10 and then 30 seconds over here. So 10 plus 30 is 40. So at the 40th second mark, it stops staying at constant speed over here. Okay, so we can remove this, and now we have our final thing where it slows down or decelerates. When it decelerates, it slopes down, and the slope is negative, so it goes downwards. When it slopes downwards and stops at B, what happens is this point over here, it's still 20, and we have the x coordinate here, it's 40. We want to, they didn't specify what time it like fully stops. In order to find the time it fully stops, we have to do, again, y2 minus y1 over x2 minus x1. Now we know when it stops, v is equal to 0. So we'll do y2 minus y1 over x2 minus x1. Now remember, x represents t, and y represents v. I'm just writing this formula again. So what's this y2 over here? I guess we'll adjust y1 and y1 and x1 as over here. It will be, the x coordinate is 40, so we'll write 40 here, and the y coordinate is 20, so 20 here. Here our first coordinates x1 y1, and y2 x2. We know that y2 is 0 because when it intersects the like the x-axis or the t-axis, we can say the velocity is 0, or in other words, y2 is equal to 0. So we could say 0 minus, and then we'll just put y1, which is 20, minus 20 over x2, which is still unknown, we can call t2 now, minus x1, which is, where's x1? Yeah, x1 is 40. Okay, so now that we have this, the slope is normally used to find, yeah, this is the slope formula, and the slope here is minus 4. This is the formula used to find this, the acceleration here, and it's the deceleration, but acceleration, deceleration, same idea. So now we'll have minus 20, t2 minus 40 is equal to minus 4. Then we'll have, once you simplify, you'll have t2 minus 40 equal to 5. t2 is equal to 45. So now we know that this point over here is 45. So now we know, now we have all the values we need to find the distance to get from point A to point B. And this is point B, keep in mind. And when we have a VT graph, what we have to do, we have to find the area under the curve. Now remember, the over here, I'll just erase. Actually, we don't really need to erase. We should just know that from here to here, to 10 to 40 is 30 seconds. So 30 will be the distance here. And from A to B, it will be 45 seconds, 0 to 45. So 45 at the bottom. And we have our height as 20. So now we have big base, which is 45, plus small base, which is 30, over 2, multiplied by 20. Cancel 10. You get 75 times 10, which is 750 as our displacement in meters. Okay, now question 4 over here, it's easy enough. They're stating, they're giving the phases of how a car is moving. So they already give phase 1, phase 2, phase 3. We're not going to read all that. We're going to start here. Phase 1. So phase 1, let's see here. They're saying that the acceleration from rest is 3 meters per second squared. And then it reaches a speed at 18 meters per second. So how do we find so if it starts from rest, we have to find the time. How do we find the time? We use this formula here. Now V0, we can cancel it out because they stated that it is from rest, which means V0 is equal to 0. So we'll just have V equals AT, and they're asking for the duration, meaning they want us to isolate time in this formula. So V over A is equal to T. V over here is 18 and A over here is 3. So 18 over 3 is equal to 6 seconds. Because they gave it to us in meters per second, so 6 seconds. The distance traveled in phase 1. Now when we want to find the distance traveled and we have acceleration and we have velocity, what we do here is we use the normal formula. X equals 1 over 2 AT squared plus V0t. Yeah. So, and there's no x0. If they don't state x0, that means if it's starting from us and they don't state anything about the initial position, then x0 will not matter. So we can just already cancel that. And we already know that v0 is 0 as stated over here. It's from rest over here. So if it's from rest, that means we also cancel this out. So now we just have this. And they gave us the acceleration, which is acceleration, which is 3. And time, which we now just got, is 6. So 6 squared, which is 36 times 6. 36 times 3 times half. It's going to be 18 times 3, which is 54. Okay, now I have 54 meters, so I got 54 here. Now let's see the total duration of the car's motion. So we'll just find the time in each interval. Now they already gave us the time in the final interval, so we have 9. We already have the time in the first interval, which is 6. So 6 plus 9 plus the second interval over here. They gave us the car then moves a further 360 meters at a constant speed of 18 meters per second. Now here, instead of using last time we used v equals 18, now we'll use x equals vt plus v x0. Again, they didn't give us x0, we can just neglect that. So we have x equals vt. We want to again find the time, so we isolate the time by doing x over v is equal to t. They said further, like distance, so like we'll just assume x is 360 here. Well, sorry, we won't assume. I don't know what I'm saying here. They already gave us the distance 360. That's all we need, and they gave us that it's like now the constant speed at the through this distance is 18 meters per second. We divide and we get 20 seconds. Now that we have the middle time, like the time at the second phase, we have the time in the first phase, which is 6. So 26, and over here they already gave it to us, it's 9. So again, let me write this, 629. 9 plus 6 is 15, 15 plus 20 is 35. 35. Now the total distance traveled by the car. How do we get the total distance? Now to get the total distance is when we use the graph, which we'll do very easily and quickly. Now fortunately they gave us most of what we need. We have the full time, which is excellent. Now we can just, sorry, let me write this better. Okay, so let me just go do this quickly. It's a v and there's a t, and it's beginning to increase 3 meters per second squared until it reaches 18. So we'll call this 18 over here, 18 meters per second squared. Sorry, just 18 meters per second, sorry. And then it reaches this speed, and then it, like for 360 meters, it constantly stays like this. But we already got the time interval over here. If we don't remember, here it was 6, here it was 20, and here it was 9. Just keep that in mind. So from here, again, from here to here, it's 6. From here to here, it's 20. And from here to here, which is when they're saying that it decelerates to rest. We don't need to know the velocity. We don't really need to know the deceleration. They just know that the time it takes to decelerate is 9. Now this is completely off scale, but it's fine. We don't really care. We just want to know the time intervals, and yeah. So we have height 18 over here. So this is our height 18. We have this top over here, so remember, this over here is going to be 6. So like this is times 6. And then 6 plus 20 is 26. So it stops here 26. And then 26 plus 9 is 35. So 35, as we stated here, 35 seconds is the final time. So we put 35 at the end here. So we'll just mark each time 35, 6, 35, 6, 26, and 35. And we have the height. So over here, the distance here will be 35 at the bottom. And on the top, it will be 20. So now we'll just do 20 plus 35 over 2 times 18. Let me just do this on the calculator. 55 over 2 times 18. You get 495 meters. Now, I know it's been 20 minutes. We want to do 5 questions, but I want to thoroughly explain it so then you guys fully understand it. Over here, average acceleration, we just have to do y2 minus y1 over x2 minus x1. Now, I'm sure we already learned through this now. We know that y is basically just v in this idea, so we can do v2 minus v1 over t2 minus t1. Change in velocity over change in time. So over here, they're saying when they're saying average acceleration in the VT graph, we have to find the secant in here, or just, it doesn't really matter. We just have to find this first point and the final point. So let's just have this here. We have this here. The coordinate here should be 0, 2. And over here, the coordinate here should be, over here, x coordinate's 5. So it should be 5. And they didn't really state anything about what this bottom thing is over here. Yes, look, over here, they gave to us here that, like, if this is 2 over here, that means, and if this is in the middle, this would be 1, and that means this over here is minus 1. So that means we know that this bottom over here, the y coordinate here is minus 1, and the x coordinate here is 5. So we have now 5 minus 1 as v2, t2. Sorry, yeah, t2, v2. And we have 0, 2. So now we use these coordinates. We'll just write them down over here. 2, 0, 2, and 5 minus 1, and then we'll just set them up in here. V2 is going to be minus 1, V1 is going to be minus 2 over T2, which is going to be 5, and then minus 0. So minus 3 over 5, which is minus 0.6. They're asking for the average, so it's going to be minus 0.6. There's our average acceleration. It's not really accelerating, it's decelerating. But yeah, now I have the idea. Okay, now we won't be needing the board here for much, so this one should be easy enough. When it speeds up in the positive direction, when they say speeds up, that means acceleration is greater than 0. And when it's saying in the positive direction, v is greater than 0. When a multiplied by v is positive, that means wait, over here we don't really care. Sorry, that means it's they gave it to us speeding up, so positive. When it's slowing down in the positive direction, so that means in the VT graph here v is like in the positive, so the v plus like over here, and the and the acceleration sloping down, so it can be like this for all we know, then acceleration is negative. So we have it as negative, and a bicycle speeds up in the negative direction. So when it speeds up in the negative direction, that means when it speeds up in the negative direction, that means it's still positive actually. Why it's still positive? Okay, sorry, these two are wrong actually. I put that it's changing signs, but over here, when they say speeding up, that means the slope is positive, and when it's in the negative sense, that means over here it's happening in the negative like sides. So this is how they're kind of explaining it. So that means when it looks like this, sorry, when the thing speeds up in the negative direction, that means it should be speeding up in the sense of like where it's negative, and that is also negative, because when it's speeding up in the negative direction, that means a has to be minus and v has to be minus. So that means they already stated v is minus. Negative direction means v is minus, so that means a also has to be minus if it's speeding up. So a is less than 0. When they say a bicycle slows down, that means AV has to be less than 0, and if they already gave it to us again, v is negative, so that means if this is negative and it has to be less than 0, that means a has to be positive, so a is greater than 0. Okay, moving on. They say total displacement, easy. This might be the easiest one, so we just do height. We just have to find the area under. Wait, we obviously first have to see if this is VT. Yes, VT. So we have our height here, which is 6. Our base here, which is 80. So we just have to do base times height over 2 for a triangle. So we get 240. A runner passes the start line at a speed of 1 meter per second and accelerates at a rate of 0.5 meters per second squared for 10 seconds. Displacement. During these 10 seconds. So they say that once it passes the line, v0, which is over here, like as soon as this passes through the start line, v0 is equal to 1. We'll just assume start line means x0 is equal to 0, so x0 is equal to 0, while v0 is equal to 1. And accelerates at a rate of 0.5, so acceleration 0.5. And now, with acceleration, with velocity, we can do now this formula over here, in the UARM, 1 over 2 at squared plus v0 t plus x 0. Obviously x0 is equal to 0, so we cancel that. v0 is equal to 1, so we can just write plus t. And half at squared, so we already have a, which is 0.5, so it will be 0.25. 0.5 times 0.5, which is 0.25. So, and then t squared, which is equal to, we don't know yet. To find what it's equal to, they said that during these 10 seconds, so we have to substitute time with, remember this is equal to x, so we have to substitute it with 10. So it should then be 35, because 25 plus 10, which gives 35. Okay, now we're moving fast paced, so this is a lot nicer. Let's look here. They're asking for the displacement of the object is, so they just want the full thing. They want, this is again VT. So to find the displacement, we have to find the area under this curve here, and then we have to find the area under this curve here. Now, to find the area, now we know displacement, it can be negative, it can be positive. That's why, once we have the area, normally in any cases of like simple geometry, we know that area cannot be negative, but this is an exception. Displacement can be negative. So that means we have to count over here the area over here as negative. Wait, sorry. Over here, this area over here as negative. This one here is less than 0. Okay. So let's first find the areas. Let's really quickly do this. So we have height 6 and base 2. Sorry, 4. The base is 4, so 6 times 4 over 2. 6 times 4 over 2, which is 12. So we have now the shaded area here, it's 12. So we have the first one, it's 12. 12 is the area of the first one. And now they want the second one where it's in the negative sense. Over here, if the y is negative, then if the y is negative, that means over here, look, it's negative. That means the displacement has to be negative. So look here, the height here will be, let's look here, the height here will be, we'll first count everything as like normal, right? We have height 6, we have base from 4 to 12, so it will be 8, and we have from 8 to 10, which is going to be 2. So we'll do big base plus small base for this trapezoid. We have, I'm just going to do this all over here again, sorry, 8, 6, 2. So we'll do 8 plus 2 over 2 times 6, which is equal to 10 over 2 times 6, which is equal to 5 times 6, which is equal to 30. And now, knowing that this is 30 meters, and this is in the negative direction, 30 meters becomes negative 30 meters. So now we have over here, we can finally conclude over here that the shape over here that we have has the displacement minus 30 meters, and the triangle over here is 12 meters. So now we just have to, to get the displacement, total displacement, you just have to add 12 plus minus 30, all m, is equal to minus 18 m. Okay, a block initially moving. Okay, so when they're saying initially moving, that means it has v0 is equal to, so look, right, we have v0 here, it's equal to 20. And it's decelerating at a constant rate of, when it's saying decelerating, that means acceleration is, no, it's like this, and it will be a is equal to minus 4 meters per second squared. And they're asking what's the displacement of the block over a course of 6 seconds. So first, let's write this formula here. If they gave us acceleration and velocity and they ask for displacement, already we know that displacement is delta x equal to, no wait, we already given most of our questions that x is equal to 1 over 2 at squared plus v0t plus x0, but delta x is equal to, in any cases, it's just gonna be like only this part here, because x0, once x0 moves to the other side, x minus x0 is equal to delta x. So delta x is equal to half at squared plus v0t. Okay, now half at squared, we have a, which is minus 4, not 4. It's decelerating, so it's minus 4. Okay, let's look here. Okay, so we have minus 4, and then we have t squared. We'll keep it t squared for now. And we have v0, which is 20, so plus 20t. is equal to delta x. Now they're asking for the displacement over the course of 6 seconds. So t is equal to 6. First, let's just simplify this. Minus 2t squared plus 20t is equal to delta x. Now we'll just substitute t with 6. So 36 times minus 2 is minus 72. And 20 times 6 is 120. So minus 72 plus 120 is 48. So now we have over here 48. So distance covered, okay, we have Boeing 747. Is an airplane that accelerates from rest to 80 meters per second at a rate of 2.5 meters per second squared. So we have acceleration, we have velocity, but we do not have time. When we don't have time, we have to use the time-independent formula. V squared minus V0 squared is equal to 2a delta x. Now now we have V0, right? Which is rest. When it's from rest, that means V0 is equal to 0, so we can cancel this. We only have we have V squared actually here. V is 80, so V squared is going to be 80 squared is equal to 2, and they gave us A here, which is 2.5, so 2.5 multiplied by delta x. Now, distance covered is delta x, so we do 2 times 2.5, which is 5, and then we move 80 squared, which is, I'm sure, 6400 over 5 is equal to delta x. On the calculator, this will show, 1,280. And the time needed for the airplane to reach 30 meters per second. Now, this is where, again, we have to use x equals half at squared plus v0t. Sorry, is delta x. Okay, here. And over here, time needed to reach the 30 meters per second speed. No, wait. How can we use this here? Okay, we do not need to use this formula. I'm very sorry. I'm wrong here. This is wrong. Instead, we have to use v is equal to at plus v0. We do not have a v0. v0 is equal to 0 because it starts from rest. However, we can still do v is equal to at, and they gave us t over here already, which is 2.5. Sorry, but they already gave us a over here, which is 2.5. And they said they want to reach 30, so 30 is equal to 2.5t. So 30 divided by 2.5, which is 12. Wait. Okay, so guys, listen, I tried methods. T is equal to, it's supposed to equal to 12, but I don't see any t equal to 12. So I believe there's a mistake here. I don't really know the answer here. I'll just put 12.8. It's the closest thing to 12. But I'm sure that's wrong in this quiz. Okay, now over here, there's a trick here. They give to us kilometers per hour. When they give us kilometers per hour, we do not want kilometers per hour. What we want is meters per second. How do we convert kilometers per hour to meters per second? We have to go divide it by 3.6. So 54 divided by 3.6 is, it's 15 and meets 15 meters per second, and then it decelerates down to 36 over 3.6, which is 10 meters per second. So it decelerates by 5 meters per second, and while traveling distance 62.5. So to find the acceleration, so to find the acceleration, we have to do v squared minus v0 squared, v0 squared equal to 2a delta x. So we know that here now that v initial here is 54. Sorry, not 54. I was about to put 54. We have to remember our new labels here. V initial is this is v initial, and this is v final. But we don't really have to label it as v final. So here we'll just write 10 squared minus 15 squared, and then is equal to 2 they gave us they didn't give us the acceleration. However, they did say that it covered 62.5, which is delta x. So 62.5 times 2 is 125. 125 over, wait, this 100 minus 100 squared. So this is 100 minus 225, which is minus 125 minus 125 over 125 is equal to A, which is equal to minus 1 meters per second squared. Okay, so if the bus keeps decelerating at the same rate from 54 kilometers per hour, it will take blank seconds to stop. So if the bus keeps decelerating at the same rate from 54, okay. So how do you know if it keeps decelerating until to stop? That means you have to reach you have to get to the point where v is has to equal to 0. Not v0, but v. But here they're including time, so that's another issue we encounter here. Okay, well, this is actually a lot simpler than it looks. The 54 just caught me off guard. We should remember that this is 15 meters per second. So we have we know that this already starts from rest. Wait, no, this doesn't necessarily start from rest. But the idea is that we can just do like v equals at, and to decelerate to 0, v minus v initial, so it has to be minus 50 minus v0. Since if you wanted to go to rest, that means v represents v final, so v0, while v initial is 15 meters per second, not 54 kilometers per hour, so we do 0 minus 15. So delta v is equal to, or just simply, yeah, it's, and then we put the acceleration in, which is minus 1, and then t is our unknown value. So minus 15 equals minus 1. T is then equal to 15. Okay, the distance covered by the bus, the distance covered by the bus covered before coming to a stop is, okay, well, yeah, over here to find to find the distance covered, we have to do, I'm pretty sure, the normal formula here. X, now we can use this formula finally. Half at squared plus v0t plus x0. Now there's no x0, I'm sure. They didn't state it, so we'll just neglect that. And we'll just have this. And then we'll just put 1 over 2 minus 1 t squared. And then v0 is 15, not 54, but 15. We already stated that 54 kilometers per hour is 15 meters per second. So plus 15t is equal to x. So now we have minus 0.5 t squared plus 15t is equal to x. Wait, they said time covered. No, they just want, like, in general, how much time it took to stop. And we already found it, which is 15. So now we just have to substitute 15 in here. So what we do here is we do minus 0.5. Wait. Minus 0.5. Multiplied by 15 squared plus 15 is equal to, so you just have to do 15 squared times minus 0.5 plus, again, 15 squared, which is 112.5. So you get 112.5 as our answer. Okay, now the total distance covered by the car. Okay, let's look here first. They gave us the time. Now this actually came in math, like a similar question somehow, like came in like a lot of prep lists. But this is like, this kind of gives off the same idea. Okay, now look here. When you ask for the total distance, what we have to do first, they gave us the time, right? And they gave us the distance and the speed in each interval. Like on the first interval, it took 60. They were going at 60 kilometers per hour, and then for the rest of the journey, they were going 80 kilometers per hour. Now we know that we know here that x is equal to vt. So what we do, we want to isolate t, because we already have the total t, so we'll get x over v is equal to t, and we know that t total is equal to 2, which is also equal to the x taken by the first x, which is 75 kilometers, over the first v, which is 60, plus x2 v2, which is which is obviously the rest of the journey, 80 kilometers per hour. However, we do not know the distance covered in that interval, and will equal to 2. Now, we do not convert anything here because they did not put anything involved in meters and seconds. They gave us hours, kilometers, so we keep everything as is now. Not like the previous question, I'm sure it was. So we have x1 here. x1 will be 75 over 60, because v1 was 60, plus x2, which is unknown, but v2 is known, it's 80, and we'll equal that to 2. So x2 then should be equal to 2 minus 75 over 60 times 80, which is 60. So now we have x2 is equal to 60. And we know that total distance is just x2 plus x1. x1 we already know is 75. So now that we have 75 plus 60, it should be equal to 135. The instantaneous speed of the car 50 minutes after it has started its journey. So 50 minutes, it's 5/6 of an hour. So to find the instantaneous speed, okay, well, look here, right? We can do v is equal to v0 t, sorry, no, is equal to at plus v0, and v0 over here for us. Now it depends, right? They already we have to find the specific time in each interval. Look, we have it right here, 75 over 60 in the first time interval, and now that we have x2 over here, second time interval will be 60 over 80, or in other words, or another number, like just 3 over 4. 3 over 4 hours to be specific. So you see, you add like 3 over 4 hours plus 75 over 6, 5 over 4 hours, and that normally, that's how we got 2 hours. And over here, we'll just use 5 over 4, like if the time is below 5 over 4 hours, or 1 hour 15 minutes, then that means that that means the speed has to be 60 kilometers per hour. But if it's past 1 hour and 15 minutes, or 75 minutes, if it's past that, that means the speed is 80 kilometers per hour, which it is not past 75 minutes. Now they're asking for the magnitude of the average velocity. Average velocity is just the total distance over the total time. And they're just asking for the magnitude. So we have 75. We already got x2, which is 60. So we got 75. Actually, they already gave it to us. Yeah, they gave us 135. And now we just have to find the total time. Total time is 2 hours. So now we just do 135 over 2, which is 135 divided. It's just 67.5. Now over here, it's easy enough. Displacement of the car over 20 seconds. Now, here, I think they did a trick over here. What they did, they added the little line here, which means that the length under this area is not 20, it is actually 19. So we'll first find the displacement over here, 19, and then over the bottom here should be 19. The height here is... I want to put it to full view because it's not in full view. It's really uncomfortable here. Very uncomfortable here. Okay. I'll just put the scale here. Okay, now I'll do this again. Over here, from here to here, it's 19. So we write over here 19. And from up, so we'll write here 19 here. And then on top, it's over here, it shows that it is from... I believe that's 6, 7, 8. Okay, so from 8 to 14. So 8 to 14, 14 minus 8 is 6. So that means the top is 6, and the height is 20 to 0, which is 20. So the height is 20. Now that we have the big base, small base, we have to do 19 plus 6 over 2 times 20. 19 plus 6 is 25 over 2 is 12.5. And 12.5 times 6 is 75. So now we have the total displacement. The average acceleration, so to find the average acceleration over the course of 20 seconds. So to find the average acceleration, we have to go from, look here, it's 0. Why is the average acceleration here 0? Because over here, acceleration, the average acceleration is equal to v final minus v initial over change in time. Over here, it reaches the final velocity is the same as the initial velocity. So that means when they subtract each other, it's 0, making the acceleration 0. So once they meet the same axis again, in the VT graph, then the average acceleration 0. Not the average velocity, but the average acceleration. Okay, the distance traveled by the car is equal to the displacement, because over here they stated that it's in a straight horizontal road, meaning it doesn't go left, it doesn't go right, it's just a constant straight line. Displacement, it always has to have change in direction, but like in this case, distance is equal to displacement because the car does not change direction. Now, final question, finally, we have here the motorcycle moving initially from origin at 2 meters per second. Okay, so we have V0 over here, it's equal to 2 meters per second, gave us, and moving positive direction, so it stays positive. And it accelerates, so A is equal to 0.4, and it accelerates for 60 seconds, so T 60. So here, velocity of the motorcycle at T equals 30, so we have to do the formula here, V is equal to AT plus V0, and we can actually use the V0 here this time, so 2 plus over here A is 0.4, and they gave us T as 30. 0.4 times 30 is 4 times 3 is 12, and 12 plus 2 is equal to 14, so 14 meters per second. And then we have average velocity of the motorcycle over the interval 0 to 60 seconds. How do we find the average velocity? Okay, now over here, to find the average velocity over here, we have to first find the total distance. Now how do we find the total distance? We have to do x equals half at squared plus v0t plus x0. There's no x0, so we just ignore that. So v0 is 2. Here a is 0.4, so 0.4 times half is 0.2. So we have 0.2t squared plus 2t is equal to x. Now we just substitute 60 in here, and we get 3,600 times 0.2 is 720, so 720 plus, and we substitute in here 120. We have the total distance in this time interval, which is within 60 seconds. So 720 plus 120 is added times it's plus, so it's 840. And now we have 840. We just do total distance over total time to get 14 meters per second as the average velocity. Hopefully, inshallah, we got everything correct. Let's see. Okay, we did. Oh my god, we have 3 mistakes. Yes, this one we already expected. Here, I think I just did a typing mistake here. I'm not sure. We'll redo this question here. One question, by the way, just keep in mind, always keep in mind over here. I don't know why this is wrong here. This, I feel like they made a mistake here as well, but let's see. Distance covered by the bus before coming to a stop. So let's see. To do that, we have to do the x equals, again, half at squared plus v initial t plus x0. x0 is equal to 0. Remember, 54 kilometers per hour is 15 meters per second, so that's our v initial, so 15t plus acceleration over here is -1, so it's going to be minus 0.5 t squared, and it's equal to, we don't know what it's equal to, but we do know that the time it takes to stop is 15, so we put squared in here. I think I just did some substitution method wrong by accident. Very dumb mistake from me then. Just give me 1 minute to substitute. I don't know what's wrong here then. I'm sure this is supposed to be 112.5. Let's continue checking. Over here, the displacement of the car over 20 seconds. So let's see here. 20 seconds. So yeah, this is supposed to be, we have to do the area under the curve here because it's a VT graph. So let's see. Again, height here. I think I just had a small miscalculation, very small. So we have again here 6, 7, 8, and then it goes until, I'm sure it goes until 14. So 8 to 14, which means the top base is 16. 6, and the bottom base is 19. So 6 plus 19 divided by 2 times 20 is 250. Sorry. Okay, well, we fix this one for sure. Okay, so 14 should guarantee be correct. 11 should guarantee be wrong. 12. I seriously don't know why. Guys, I'm very sorry. I forgot to estimate it. So guys, everything over here has been correct. They only made a mistake in question 11. Here, I'm sure 100% that this is incorrect. So guys, I did not waste anybody's time. I just did some very, very small stupid mistakes. Everything's still correct here. There's no misinformation. You've been fed. So even if you left the video early, which fortunately, if you're still watching, you didn't, everything's good for you then. Over here is the only mistake I made, where I got 75 as my answer. Hopefully you watched this full video. I mean, I know you did not watch 52 videos, and we all know that. But just skip if I'm talking too much or the question's too easy. I like to explain too much, so you just skip it through whatever. And if you find the question that you really need help in. Hopefully this video helped you deeply. I'm sorry I'm posting so late, and I'll see you tomorrow, guys. Thank you.